Hello and welcome to part 4 of this little tree generation series. So last time we generated this tree here, and in this video I'm gonna make it a little, make a few additions to this. So if we open up the blueprint and take a look at the generate tree, actually what I wanna mention first is that right now the width of the branch or the trunk or whatever it's called is the same all over the place. So what I wanted to do is to become thinner the further up we get. So I'm going to do that by introducing a new width scale, which I'm going to make a float and expose that. And per default, I'm going to set this to 1. So the idea behind this is that if I set this to 0.9 or something, and then I'm going to multiply the scale by this value every time we create a new segment. Okay, so if we jump into the branch structure, we can see that currently we don't have a way to store that information. So the most obvious place would be to store it in an array, just like the points here. But I'm going to do something different in this case here. I'm going to change this in a way later on, but for now I'm just going to create a width scale here as well. And this is actually the parent width scale. So to begin with, when we generate our tree, we can see that we generate over here to begin with, but right now it has a parent width scale of 0. So I'm going to create a new local variable to hold this value here, which we're going to change constantly. Call this local width scale. And when we start to generate the tree, we're going to set this to 1. And we can also feed that in here. So next, what we want to do is to take that width scale, whatever it is, when we create a new branch, and then save it here. So the last part we need, or almost last part, is that when we move forward, what we also want to do is to take that width scale and update it. So we're going to take the width scale and multiply it by the width scale, the public one, and then update that local value here. So that means that it's getting smaller and smaller for each time we move up a segment. In order to update the spline mesh itself, we need to do something similar over here. So since I chose not to save them for each segment or each point themselves, I need to do something different. So here I will also something similar. So I need to set start scale, and the start scale needs to be the scale is to begin with. So I actually need a way of keeping that value as well in here. So I'm going to create also a local width scale here, which I'm in this case I'm going to set like this. So that means that for every time we loop for each branch, I'm gonna add this comment here, and then this one is for each spline point. Okay, so we have this width scale here, and we also need to update it. So the set start scale actually takes a 2D vector. So in order to get something meaningful out of this, what I'm going to do is to take this width scale here, and I'm just going to feed that into both the X and the Y. So after that, I need to update the end scale. And I need to set it to the same basically, but this time I will decrease it a little bit before I set it. So just as we did up in the other one, I'm gonna set this in updated to be the width, the public width scale multiplied by that current. Like this. Okay, so let's compile this and take a look at what we have now. So something looks wrong. What did I do wrong? I may have forgotten one thing. So when I create a new branch, I save it here, but then when I return back again, I also need to restore that value. So need to set this back again here. And that doesn't look right either. Hang on a sec, what is this? It's the parent with scale. Oh, I see. I put this at the end. So actually what I need to do is put it before I update the branch index. Otherwise I'm gonna get the next. There we go. So now it looks different. What the heck? Where did the rest of them go now? Oh, awesome. Okay, this looks a little bit better. Alright, so now we can see that it's scaling the branch sizes down a little bit. And I still need to sort out the rotation so it looks more like a 3D tree. And so that's the last thing I'm going to do. And for this, I'm going to say whenever I create a new branch, I want to rotate that point here when I put it in before I put it in here. Yeah. So I'm going to take this part here, move this a little bit to the side, and then I'm going to say the turtle, I will add something to the local rotation, and once I've done that, I'm going to add can I somehow okay, sorry for being a little bit anal about this. Okay, and what I need to add here is something to the roll. So I'm going to create a new variable again, call this, I will call this roll, make it public, and I think I'm going to give it the default value of this Fibonacci angle, and then I'm going to add this to the delta rotation here. So let's compile that and see what we get. So as you can see, nothing seemed to happen as I would have expected it to. But the thing is, I think I mentioned something about that earlier on. If I use add relative rotation as I do up here, you can see I use local rotation, and the reason for that is that I actually need to do a add local rotation up here as well. We can remove these two. So instead of using relative rotation, I need to use local rotation. Now we can see it starts to look more 3D, and we get some kind of rotation at least. And I'm not 100% sure about the rotation angles, if they are correct. It looks kind of wrong to me. I would have expected it to be more evenly rotated. So actually at this point I'm not entirely sure if this is correct, but I'm just gonna keep it for now, because anyway later on I'm gonna rewrite a lot of this stuff here about the rotation, I think. So I'm not gonna spend too much time on this for now. But one other thing I wanted to add to this is to introduce the randomness factor. So if I just find, let's see, we can add it whenever we move, we'll introduce a little randomness. So if I take out my turtle again and add local rotation, and then I'm gonna figure out what to input here. So I'm gonna add 3 things here. So one is I'm gonna call random x, and this is gonna be a 2D vector. And just gonna duplicate this one and duplicate it again, and then call this random y and random c. So I'm also gonna make all of these public, and then I'm gonna say for the random x, I wanna drag that out and split it up and say I want to get a random float in range between these two, and then plug that in here. And I'm going to do the same with the next. And finally with the C. And compile that and save. So when I now select my tree, I have these here. I can enter something into, so I can enter like -5, 5, and -5 and 5. So now you can see that it starts to generate some randomness at each step. So if I add something like then we start to get something looking a little bit more like a tree. So obviously you don't want to have these blocky spheres here as I have. You want to have something else instead of that. I'm actually wondering why I have these holes in them right now. I wonder, no. I wonder if I did something wrong with my spline mesh. So here I add the spline mesh. And didn't change anything. Anyway, it's not like it's crucial at this point, so for now I'm just gonna leave it. Anyway, so this setup here basically allows us to create all kinds of random trees quite easily, and you can just tweak the rules over here, the F or the G rules, come up with your own rules sets. So plus F, see what that gives you. So you can see it doesn't take too many changes, and then it's going to change quite drastically, so depending on what you input here. And what you also can play around with is the angle itself. So maybe only change 10 degrees. You can also play around with the length, so make it longer. And also maybe change the width scale so it becomes thinner a bit faster. There's a lot of things you can play around with here. For example, let's add another branch here, say minus f something. So I guess it's mostly a matter of just experimenting and see what you come up with, what it creates. Okay, I think I'm gonna leave this here. I could obviously improve a lot on this yet, but what I'm gonna do instead is to actually park the L systems here and let you guys experiment with them, see if you can come up with some nice configurations, and maybe add some improvements to this besides what I done already. So yeah, hope to hear from some of you guys watching this, and let me know if you create something cool. So that's it for this video, and I might continue in the next with a different approach, the one I shown in the first 3 showcase videos or work in progress videos. So stay tuned, and bye for now.